let's come here in the contract, and now we have to create the first smart contract. So let's create the file for that, and this time the smart contract we're going to call it swap token.sol. okay, so this is the file name I have given to my smart contract, and here we are. So we'll go in this way. First we'll write the smart contract for the single swap, then we'll write the script for testing. So when we get succeed in that, then we'll move to the multiple swap, and then we'll test, and that's how we'll take ahead. Okay, so let's do one thing at a time. So let's write the contract for the single swap first. So you know the drill, we have to provide the general configuration. So we have to provide the solidity license identifier, and this is the recommended which I'm following from the Uniswap documentation. Okay, so this is the exact license identifier you have to provide. We have to pick the pragma solidity version, which is a recommended one is this. So make sure to pick the same solidity version, otherwise you guys will have an error. Okay, so make sure to pick the solidity version between these range. It's greater or equal to 7.0 or less than 9. And you might be wondering that what is ABI encoder. This ABI encoder v2 will allow you to use nested array in your smart contract struct, and that's why you have to use it, because internally our smart contract which I'm going to write, it uses this. And now we have to import couple of packages. So we need to import the, let's come here, open up your terminal. So before we start importing, we have to install the packages which we want to use, like Uniswap v3 we have to install, and we have to install other packages. So let's install all those packages. So let's come here and we can type this npm I Uniswap v3 periphery. Hope I'm pronouncing this name correctly, periphery. Okay, so this is the package which you have to install. Hit enter, and this will happen very quickly. So here we have installed the first package, and now we have to install the second package. So let's remove this, and this time we have to install OpenZeppelin, and this is the package we're going to use to build our ERC20 token, which we're going to use to swap. So let's install this. So here we have installed that, and now we have to install the other package. So we have to install the ether. This will allow to interact with the contract, and now we have to install the web3 model. So right now we have to install 4 these packages. Just wait, it's installing. So here we have all the 4 important packages we have installed, and now we can start importing those packages in our contract. So let's come here, let's go to this, and you will find, if you open this packages and file, here you will find that we have all the packages. So make sure you have to install the exact version. You can get the OpenZeppelin, the updated one, but when it's come to the Uniswap, you have to pick the exact version v3, then it will work. So this is the version you have to install. We have the ether, and we have this web3 model, and this is the dev dependency we have. So now we can start importing those files. So we have this v3, simply remove this one, and we have to import. So let's come here in the node modules, and first you have to find out. So I just want to show you that from where we are getting this file. So you guys have to know that how we are importing and what we are exactly importing. So let's come here and let's try to find out the Uniswap, where it is. Here we have this Uniswap entire folder. Inside the Uniswap we have this v3 periphery, and that's the one we are using. So we have v2, we have v3 core, and but we have v3 4. So but here I'm going for the v3. So let's type Uniswap /v3 periphery and let's open this folder, and inside that you will find couple of folders. You will find the artifact, you will find the contract, node modules, license. So we have to get into the contracts. Open the contract. Now we have to go into the library, and inside the library we have this smart contract, and the contract we want to use is, let's say, this one, transfer helper. So this will allow you to do the transfer. Okay, so make sure to import the exact folder which we're going to use. So right now I'm getting this error, it says wrong file casing, and now you can see the error is gone. We don't have any error. If you have any error, make sure to provide the exact path which I have provided, although I will provide you the entire code in the file, in the starter file, so you can compare from there. Okay, so let's import the other package, and that's the other package we are using, contract interface ISwapRouter. This will allow us to do the swapping. So make sure these are the two packages you have to install. And we have this one, interface, ISwapRouter. So these are the two packages, and now we can start writing the contract. So let's type contract, and we're going to call this contract single swap token. And here we have to define our swap router. So we'll say swap router public constant, because this router is, the address of this router is not going to be changed, it's going to be permanent. And that's why I have defined constant, because when I will deploy the contract on any network, it will cost me less. So I believe that you guys haven't forgot this concept which we have discussed in our smart contract in our Solidity course. So make sure to follow that Solidity course to have a better understanding of each of these keyword, each of this function which we are creating here in the contract. So here we're going to say swap router, and there are two ways to provide the swap router. You can do it in the constructor. So at the time of deployment, you can pass the swap router in the constructor and you will update that, or you have the other option, you can do it like this, provide it straight away, because you know that this is the router which is not going to be changed. So I will go in this way, I'm not going to provide through the constructor. So I have already saved it. So this is how you have to define. You have to define ISwapRouter, and you have to simply paste the address of the contract. So this address is deployed, so this swap router contract is deployed on this address, so we are passing that. So believe that so far whatever we have covered, that makes sense to all of you. So just follow along with me and everything will make sense. So we have our swap router, and here we're going to define all the token which we want to swap. So generally what I'm planning to do is, we are using hard hat, and hard hat will provide you couple of accounts, and each of the account will have couple of ether. Okay, so we're going to swap the token from with to DAI. So that's the first swap we'll do, because we already have some width, and I'm not going to do on the mainnet because I don't have any real width, so I can do the transaction. So we're going to use it whatever hardhat provide to us. So let's provide the address of the token. So we'll say public constant DAI, and here we're going to define the address of the DAI. Now we have to say public constant, and this will say with 9, and here we're going to define this USDC. So these are the addresses of the token DAI, with, and USD. I'll provide this in the starter file, so from there you can copy. So now we have to create a very first function which allow us to do the swap. So what we're going to do is, we're going to pass a fixed amount of width, and in return we'll get DAI. So let's write the function for that. We'll say function swap exact input string. That's the name of the functions. Again, I'm telling you, I'm getting all these stuffs from the documentation, because that's the only resource we have about the Uniswap v3, and that's what we have to follow to do the swap using the swap router of Uniswap. So make sure to follow along with me. In that, we're going to pass an argument. So we're going to pass the amount in. So how much amount we want to provide into this function, and what we want. So amount in, it's gonna be external, and return, and we want to return the output, so amount out. So that's the simple function we have here, and inside the function we're going to define a couple of things. Let's try to understand that how the entire swap exactly work. So when you will call this function, whoever will call this functions, we're going to utilize this transfer helper function, and in this transfer help function we have two functions. One we have the approve, and the other one we have is save transfer. So first we have to transfer the fund to the smart contract of Uniswap. We have to approve them, so the smart contract of the Uniswap will going to spend the token on behalf of us. So that's the entire logic. Okay, so that's the only thing you have to keep in mind. So we have this import, simply copy, and that's what we're going to call it. So we'll say transfer helper, and we're going to call this method save transfer from, and in that we have to pass couple of data. So first we have to pass the token, that what token we want to provide, so with, and the other one is going to be the message.sender, the person who's calling the function, and to whom we want to provide. So address this means the smart contract, Uniswap smart contract, and then we have to provide the amount in. Okay, I believe so far everything is clear to all of you, how everything's working. First, we are transferring the fund to the contract and approving them. So we have transferred the fund. Now let's try to approve them. So we're going to call this transfer helper, save, approve, and with, and we have to call it address this, not address this, swap router, because that's the router we are approving. So it can expend the token on behalf of us, and we have to define the amount in. So that's the save, approve, and now we're going to define the ISwapRouter and some parameter, because we have to assign some data, and that's what method we're going to call swapInputSingleParams. So memory, params, and we have ISwapRouter, exactRouter, exactInputSingleParam. So this is the one we have, and inside this we have to pass a struct. So if you look at the documentations, you will find that exactInputSingleParam is just like an struct. We have to define the couple of parameter which we want to pass to our param, to our swap router. So in that we have to define. So first thing, we have to define the token in, what token we are trying to provide and to an exchange. Okay, what token we want to provide in exchange. So token in, we have to make it token out, and here we have to define the fees, pool fee. So right now I'm going with the hardcode value, but in the real world, in the production level, this should be never be hard coded. We'll have a different function which allow us to update this token fee as per the user interaction. If a user trying to swap token very frequently, so for that we're going to charge less, or maybe we can charge higher. So this should be dynamic, but right now I'm just going with the hard code because I will show you that how you can do the testing. So just for that, but later we're going to make it dynamic. So we have this full fee. We have to define the recipient, that who going to receive it, to message the sender. We have to define the deadline. So you don't want that your transaction gets stuck. You need to wait for a particular amount of time. If the transaction happened in that particular amount of time, then it's okay. If it took more than that, then you want to simply stop the transaction. So we have to define the deadline as well. And now we have to define the amount in, and we have to define the amount out. Initially we are going with the 0, but in the real world it should be never 0 for the security purpose, which we'll talk later. And here we have to define this square, price, limit. So that's the entire struct we have defined, and I think I'm getting some error. So it says the amount. So amount out we have here, and it says minimum. So make sure to do this change. And what else? And here we have to simply change the, rewrite the spelling. Okay, there was a spelling mistake, and you guys know that I make a lot of spelling mistakes. So I believe that whatever we have done so far, that makes sense. We are using the ISwapRouter and passing all this data, and here we're going to simply do the transfer. So amount out, swap router, and we're going to say ExactInputSingle, and in that we have to pass the entire data which we have inside the param. So that's the very first function which allow us to do the single swap